second related rates problem we're going to do, and this one is a little bit different. We're going to use the same setup, but it has to do with an angle this time. So, start of the problem is the same. We've got a 12-foot ladder leaning against the wall at a height of 5 feet from the floor. The top of the ladder is sliding down at 6 inches per minute. This time the question is going to be, how fast is the angle between the ladder and the floor changing? So we have the same situation as we did in the last problem, but now we're looking at what's happening with this angle down here as the ladder slides down the wall. So again, we're going to distill this to the basic math, which is a right triangle. H is the height off the floor, B is the length of the bottom, how far the bottom of the ladder is from the wall. This time we're going to add a theta because we're looking for how fast that angle is changing. So my height is still 5 feet. My dH dt is negative 1/2 foot per minute. We just changed inches to feet. In this case, we want to find d theta dt. I still am going to leave the length of my b up here because I might need that. In this case, we're not going to use the Pythagorean theorem because I want the change of an angle. So that tells me I'm going to use a trig function. Since I have all three sides, I can use any of the trig functions because we solved and we knew after we solved using the Pythagorean theorem that we had a 5 here and a square root of 119 here. I'm going to just start with what I had originally because my 12 is not changing. So that's going to make my differentiation a little easier. So I'm going to set up sine of theta opposite over hypotenuse. SOHCAHTOA. The same idea applies. Sine of theta equals h. Because h is changing, that's why I write that as a variable. The 12 is not changing, so I leave that as 12. I can think of this as sine theta is 1/12h. That way I don't have to use a quotient rule. What I want to find is how fast this angle is changing, d theta dt. So now I'm going to take the derivative. The derivative of sine theta is cosine theta. Theta is changing, d theta dt equals. The 1/12 is a constant, it stays. The derivative of h is 1, dh dt. I'm going to do this problem, I'm going to use the method that I did not use in the other problem. I'm going to substitute in first and then solve for my dH dt. Cosine theta. I'm going to just go through again and use SOHCAHTOA. Cosine is adjacent over hypotenuse. So the square root of 119 over 12 times d theta dt equals 1/12. My dH dt is negative 1/2. That's also not too hard to solve. So I'm going to first simplify the right side. Square root of 119 over 12 d theta dt equals negative 1 over 24. And then I am just going to multiply by the reciprocal to get the d theta dt by itself. So I multiply by 12 over the square root of 119. D theta dt equals -1 over 2 square root of 119. And when I put that in the calculator, be sure you're using parentheses around the denominator. So when I put that in the calculator, I get approximately -0.05 radians per minute. Okay, and the answer is negative because my angle is getting smaller. So these are two basic right triangle problems that you're going to see for related rates.